Welcome to the summary video for the workshop Python for Scientific Computing and Artificial Intelligence. Here we are using Google Colab again. So again, you need a Google account and you need to be logged into Google. And if you do a search on Google, you'll find Google Colab and this, what you want to open up a new notebook, and here's one I prepared earlier. So in Google Colab, you either have a code cell or a text cell. This top cell here is a text cell. To get a nice title, we simply use the hash symbol. To execute a cell, you can either hit the play button or you can just hit Shift Enter. Okay, so there's our nice title. The next cell is a code cell. So this is a code cell. We want to insert this image into our notebook. So we have to drag and drop this PNG file, PSCAI, into this folder on the left, and then we use these commands here. You can see that we've got this image pscai.png, and we set the width to 700 so that the font sizes are about the same. All delegates at the workshop will get a free copy of my book, Python for Scientific Computing and Artificial Intelligence, published by CRC Press. And the reason you want to learn how to program is obviously for employability, but also any undergraduates, hopefully you will use programming in your final year projects. The second image is itinerary.png. Again, just drag and drop into this folder here. So on day one, I'm going to start by introducing you to Python and using it as a calculator. The reason for that is because you've all used calculators before in school. Then we'll look at simple programming, how to define a function, which is similar to adding buttons to a calculator. We'll look at loops, for loops and while loops, and finally if, elif, else statements. In the afternoon, we'll look at the turtle module, which is kind of programming by drawing pictures. So that'll give you a deeper understanding of programming. And in the afternoon, numerical Python and matplotlib for producing colorful graphics. And we'll have a look at that later. Symbolic computation on day two for mathematics. So, you know, how you differentiate and integrate, etc., using the package. So the emphasis on the workshop is not the mathematics. So we get Python to do the mathematics for us. And then in the afternoon, Jupyter Lab and Google Colab in more depth. In the afternoon on the second day, we'll start with scientific computing. So we'll look at examples from biology and chemistry. On day three, we'll look at data science and economics. And then in the afternoon, engineering and fractals and multifractals. On day four, we start with image processing, numerical methods for ordinary and partial differential equations, physics and statistics. On day five, there'll be a general introduction to artificial intelligence. I'll talk about my invention on brain-inspired computing, which is only possible because of my highly interdisciplinary research. Then we'll look at neural networks, how AI works from the very basics, and we'll finish the workshop with recurrent neural networks to predict time series. I'll give you an example of that at the end of this workshop, at the end of this video, sorry, and convolutional neural networks, which used a lot in medical imaging. So if we want to insert a code cell, we simply hit this code button here, and you'll see that we can actually generate code with AI. Okay, AI is going to permeate all of our lives for many years to come, but we won't do that. We'll just do some simple programming and commands here for you. So we're going to start by introducing you to a list. So a list is one of the most useful objects in the whole of programming. So our first list we'll label as L1 for list 1, and this will be a list of numbers 1, 2, 3, 4, 5. Okay, so the list of numbers, the reason I've repeated 3 here is just to show you that you can repeat numbers in lists. So we can execute this cell with a little play button, and now Python understands that L1 is a list. If we want the type of this object, if we just type L1, and you'll see that it is indeed a list. Next, we want to access the elements in a list, so we use what we call zero-based indexing. So this is zero-based indexing. Again, this is something you have to get used to when you are using Python. So the first element is in index place 0. So L1, 0 gives us 1. Similarly, we could work out the second element. So L1, 1 would be the second element, and you can see that's 2. If we wanted the last element, we'd have L1 minus 1, so that's reading from the right. And then it's an interactive workshop, so I could then say to you, during the course of the workshop, how do you think you would access the second to last element in the list? So just looking at these examples here, what do you think the command is to get the second to last element in the list? And a lot of you will have realized that's just minus 2. Okay, so you can get some minus 2 reading from the right gives us 4. We can also work out the length of a list. So there is somebody has written a function called len. So len gives us the length of the list. So you see there are 6 elements in this list. We can also work out the maximum minimum of the list. So again, somebody's written a function max of L1. This will obviously give us the maximum value of the elements in list L1. Similarly, min would give us the minimum. So min L1 gives us the minimum element, which was 1. We can generate another list using a range function. So for example, we can say L2 is equal to a list, and then we're going to say range, and we're going to go from 1 up to, but not including 501. Okay, so what does that give us? So we can't see that yet, so we can actually just list the L2, and you can see here's our list of values, and these go from 1 all the way up to 500, but not 501. So we go up to, but not including 501. Next, we want, we'll have a list of lists. So this will be L3, will be a list of lists. So the first list will be 1 and 2, and then the second list will be 3 and 4. So this is a list of lists. List of lists. To access elements in a list of lists, if we say, for example, L3, 0, 1, then this will give us, well, let's just see what it gives us. It gives us 2. It gives us, so this will give us the second element in the first list. And then again, it's an interactive workshop. So then I could say to you, what would the command be to get the first element in the second list? So what would this command be to get the first element in the second list? So I'll let you think about that. Next, we're going to introduce vectors and arrays. So we will insert a text cell here. We'll have a subtitle. So we use 2 hashes. So this is vectors and, well, let's do it the other way around, arrays and vectors. So we want arrays and vectors. Now again, you can see Google Colab actually shows us what the output is going to look like. So this is our subsection, arrays and vectors. To work with arrays and vectors, we've got to import numerical Python as NP. And we're going to say A is equal to NP. So this is our alias for numerical Python. Within numerical Python, there is a function called arange. And we're going to do arange 5. And we can simply print out the array A, and here is our array. Okay, so again, we go up to, but not including 5. And remember, we're using 0-based indexing. We can also print out our A. And you can see this is an array. Notice there are no commas. If you remember our lists, remember L1 was a list. We had commas when we got lists. Here, there are no commas. So that's how we distinguish between lists and arrays. Next, we can convert a list to an array to a list using the function toList. We put empty placeholder just to show it is a function. And now you can see that this A has now been converted to a list. We can work with vectors. So for example, we can define two vectors, U and V, on one line. So those of you who've done A-level maths will know how to deal with vectors. So U is going to be the vector np.array, and we'll make this the vector 1, 2, and 3. So this is a three-dimensional vector. And similarly, V will be another vector np.array, and this will be the vector 4, 5, and 6. Okay, so we have two. So these are two three-dimensional vectors. Okay, so we say this is two 3D vectors. Now, without understanding any of the mathematics behind this, we can work out the dot product of two vectors. So there is, within numerical Python, there is a function called dot, which gives us the dot product of two vectors. So we can find the dot product of the vectors U and V. You can see that's 32. That gives us a scalar. Similarly, we can find the cross product. So within numerical Python, there is a function called cross. So we find the cross product of two vectors, and this in fact gives us a vector. Okay, so here is the scalar, and here is the vector. We're going to now have a look at how we define a, how we can write a little program. So I'm now going to create a list of, which consists of the elements of the Fibonacci sequence. So suppose we want to generate the Fibonacci sequence. Okay, then we want to write some input. So we say n is equal to an integer, and we will input the number of, we want to input the number of elements into this list. So this will be number of elements. Okay, so the computer will ask us to give some input, which will be the number of elements of the Fibonacci sequence. So fib will be our list, and it starts with the elements 0 and 1. So those are the first two elements of the Fibonacci sequence. Now we're going to look at a for loop. So here's a very simple program for you. So we say for I in range, and we're going to go from 2 up to, but not including n. And then we need a special delimiter, which is the colon. And then Python indents for us. So do not change that indentation, otherwise the program will not work. The ith term, which I call I term, that will equal the Fibonacci element in placeholder I minus 1, and then we add the Fibonacci element in placeholder I minus 2, and you'll understand that a bit more when we print out these terms. Then we want to append, so we use a function called append, and we want to append the ith term onto this list. And then at the end of this, we want to come out of the loop. So to come out of the loop, we simply hit the backspace, and then we will simply print the Fibonacci list. So if we run this cell, you'll see here's our input. See the input, and it has to be an integer. So let's just have a look at the first 20 elements of the Fibonacci sequence. So to get the third element, we add these two together. To get the fourth element, we add these two together, etc. And that's how we generate the Fibonacci sequence, which is famous not just in mathematics, but throughout the realms of science. And I just want to finish this summary video by showing you how you can predict time series, even chaotic time series, using artificial neural networks and TensorFlow. So a lot of you will have heard of the butterfly effect. You may have seen the film, and this is related to the Lorentz equation. So here are the Lorentz equations, which is a very simple model for the weather. So these are now very famous equations. This leads to the butterfly effect and what we call chaos. So there are three variables, x, y, and z, and we just take one of these variables, say x, and we want to plot the solution as time progresses. So these are the differential equations. We solve the differential equations, and we plot X against time. Now, if I was to give you a pen and say what happens next, this is predicting the time series. So using TensorFlow and what we call long short-term memory. So this is a long short-term memory neural network. There is only one layer with 128 neurons in the hidden layer, and then we have one output layer. We use 30 epochs, so we feed all of the data through 30 times, and the validation split is 0.2. So we train with 80% of the data and we test with 20% of the data. So this just shows us that the model is working. So we have the training data and the test data. As long as these loss curves are close to each other, then we don't have any overfitting and the model works well. So if we look at this time series, here is the historical data. So this is the chaotic time series. The blue is what actually happened and the red is the prediction. Now I'm sure you'll all be blown away by this. As I said, if I said to you what comes next, you just have a guess and try and draw it. There is no way anyone on the planet could get this accuracy. So this is predicting time series using artificial intelligence and long short-term memory. So I will explain how this works to you in the workshop. And you can even use this to predict financial time series. So we will discuss this in more detail in the workshop. So I hope to see you all again in the full workshop.